This is the review for AP Chemistry Unit 1, and these are the 4 topics. First is the percent composition, and in order to find the percent composition for each element, you first have to find the total molar mass. So total molar mass of ammonium nitrate will be 14 plus 4 hydrogen, so 4 times 1, plus another nitrogen, and then 3 oxygen, which would equal 80 grams per mole. And then in order to find the percent composition, you simply have to divide the sum of all atoms in the molecule by the total molar mass. So for nitrogen, it would be there are 2 nitrogens, so 2 times 14 divided by the total molar mass, which was 80, times 100%, which you get 35%. And for hydrogen, there are 4 hydrogen times 100%, which you get 5%. And lastly, for oxygen, there are 3 oxygens divided by 80 times 100%, which you get 40%. Next is the empirical and molecular formula. First, you have to assume that you have 100 grams of this total substance. Then you know that you have 48 grams of carbon because it's 48% of 100. And you have 4.0 grams of hydrogen, 22.4 grams of nitrogen, 12.8 grams of sulfur, and 12.8 grams of oxygen as well. Then you have to convert these grams into the moles, and you can simply do that by dividing the grams by the molar mass. So for carbon, you have to divide 48.0 grams by its molar mass, which is 12.011 grams per mole, which you get 3.996 moles. You have to divide 4.0 grams by 1.008 grams per mole, which you get 3.968 moles. For nitrogen, you get 1.599 moles. For sulfur, you get 0.399 moles. And lastly, for oxygen, you get 0.8 moles. And for the third step, you have to divide all this number of moles by the smallest number of moles, which would be 0.399 moles in this case. So you divide each of them by 0.399. And you get 10 for carbon, 10 for hydrogen, 4 for nitrogen, 1 for sulfur, and 2 for oxygen. And these will be the number of each atom. So the empirical formula is C10H10 N4 S1 and O2. The molecular mass was found to be 250 AMU, so you have to find the molar mass of empirical formula to know if the empirical formula equals the molecular formula. So molar mass of empirical formula is 10 carbon, 10 hydrogen, 4 nitrogen, 1 sulfur, and 2 oxygen, which you get is 250 AMU. So you know that empirical formula equals the molecular formula in this case. But if the molar mass is, for example, 500 AMU, then you would have to multiply this empirical formula by 2 to get the molecular formula, which would be C20, H20 and 8 as 204 if the molar mass was 500, but molecular mass was found to be 250 AMU, which you know that empirical formula will equal the molecular formula in this case. So you know that this also is the molecular formula. Next is the redox reaction. Oxidation is losing electrons, so oxidation number will go up because losing electrons is basically losing the negative charges. So if you lose the negative charges, it will be same as gaining positive. So oxidation number will go up. And reduction is gaining electrons, so you're gaining these negative charges, so oxidation number will go down. And this is an example. Magnesium plus CuCl2 will be MgCl2 plus Cu. So this is a single replacement reaction, and you have to find the oxidation number for each atom to know if each species is oxidated or reduced. So magnesium is a solid in here, so you know that the oxidation number is 0, and copper would be +2, group 2 atom, and chlorine would be -1. Magnesium would be +2, group 2 element, and -1 for chlorine as well, and then 0 for copper, because it's a solid in the product side. In this case, you see that the oxidation number for magnesium went up from 0 to 2, so you know that magnesium is oxidized, because as you can see, oxidation number going up is oxidation. And for copper, copper's oxidation number went down from +2 to 0, so you know that copper is reduced. And all single replacement reactions are redox reactions, because as you can see, the oxidation numbers of at least 2 atoms will change, and the change in oxidation number means the redox reactions. The redox reactions in acidic solutions. So it says potassium permanganate solution is added to an acidic solution of sodium oxalate. So first you have to write the equation for this whole reaction, which would be KMnO4 plus NaC2O4. And then you know that potassium and sodium will be spectator ions, which will not react, so you have to cancel them out. And then you get the redox reaction of MnO4 minus plus C2O4 2 minus Mn2 plus CO2. And you have to make this into the half reactions. MnO4 minus is becoming Mn2 plus. So MnO4 minus is becoming Mn2 plus. And then C2O4 2 minus is becoming CO2. And these are the half reactions. You have to do them separately. First thing you have to do is to balance the number of atoms on each side. So in this case, you have 1 manganese and 1 manganese on this side as well. But in this case, you have 2 carbons here, but 1 carbon here. So you have to multiply this side by 2. And you cannot forget this step, because this step is very easy to forget. And next step is to add water based on the number of oxygens. So in here, you have 4 oxygens, but you have none here, so you have to add 4 water. Because if you add 4 water, you are basically adding 8 hydrogen and 4 oxygen. And then you see that on the right side, you have 8 hydrogen, but you have none here, so you have to add 8 hydrogen atoms, or hydrogen ions. And lastly, you have to add up the charges on each side, which would be -1 plus 8, because you have 8 plus charges, which would be +7. And then you have +2 plus 0, because water has no charge, which should be 2. And in order to balance the charges, you will have to add 5 electrons on this side. Then the charge in here would be 7 minus 5, which would be 2, which equals the charge on the right side. And then you do the same thing for this half reaction. You have 4 oxygen atoms and 4 oxygen atoms in here as well. So you do not have to add any water. You just add up the charges, which is -2 in this side and 0 on this side. So you'll have to add 2 electrons in here. Then the charge on the right side will be -2 as well as the left side. So you got the 2 half reactions here. And in order to add these half reactions, you have to multiply each reaction by the number that will make them have the same number of electrons. So you have 5 electrons here and 2 electrons here, so you have to make each half reaction have 10 electrons in total. So you multiply this half reaction by 2 and this half reaction by 5. Then you get 2MnO4 minus plus 16H plus 10 electrons and 2Mn2 plus 8H2O for this half reaction. And for this half reaction, you will have 5C2O4 minus 10CO2 plus 10 electrons. And you will simply have to add these 2 half reactions. Add the reactants, 2MnO4 minus 16 hydrogen, 10 electrons, 5 C2O4 2 minus. These are the reactants. These 3 and this will become 2Mn2 plus 8H2O, 10 CO2, 10 electrons. And then lastly, you will have to cancel out the same molecules on both sides, which would be electrons. And then you will get the net balance equation. MnO4 minus 16H 5C2O4 2 minus will become 2Mn2 plus 8H2O plus 10CO2.